Good afternoon. So now I am going to take the subject engineering, metrology and measurement. Engineering, metrology and measurement. What is the meaning of metrology? Metrology is the art of measurement. So in our day-to-day life, so the measurement is an important role. We know everything. So suppose we have to buy something in the shop. So we have to buy something in the shop, the length and weight and time based, we have to measure that the measurement. So what is the meaning of measurement? So the measurement means that is the comparison of standard one. So comparison of the standard one. So how to compare with the standard? So the unknown quantity of the components, to be measured. So that is the comparison with the standard one. So the unknown quantity is called measurand. So measurand means unknown quantity of the component. Then we have to compare with this one. Comparison process. So the comparison process which we are going to compare, that is the standards. So what are the standards are available to compare with this one? Standards. So the various standards are available, various standards we have to follow. So international level and then national level. So the first one is international standard. International standard. And then next one is primary standard. And then third one is secondary standard. And then fourth one is working standard. These four standards we have to follow. So the international standard, primary standard, secondary standard and working standard. So these three standards we have to follow in the national level. So only we have to agree with the international standard. So the international standard is agree with the international level. So this standard only we have to compare with the unknown quantity. So and then finally we are getting that the result, that known value as the result. Known value is the result. Unknown quantity, that is the measurand, that compare with the standard value, then we are getting that the result. So the result our need form. So this is called measurement. So various elements, various instruments, we are using various fields. So measurement is an important role. I already told measurement is an important role. We are using in various industries, advanced industries and then automated industries, normal industries. We are using this one. So in this measurement, we are using various instruments. That instrument we have to follow various components. That components we have to use that components in the various elements. That means generalized measurement system. Generalized measurement system. What are the elements? That element feature is in a generalized measurement system. So in the generalized measurement system, it is having 6 elements. One is primary sensing element. So this one is first element. So the observe the energy from the outside, which we are going to be measured. So that is the primary sensing element. And then second one is variable conversion element. And then third one is variable manipulation element. And then fourth one is data transfer element. And then fifth one is data processing element. And then sixth one is data presentation element. These are all the elements we are using in the instruments. So in the various forms, these features is the main thing. The primary sensing element is only observe the energy which we are going to be measured. So that is the primary sensing element. Then next one is variable conversion element. So the energy is converted. So the observed energy is converted into another one form. That is the electrical form. So like voltage, frequency. So that is a conversion element, variable conversion element. And then next one is variable manipulation element. So the small voltage is and then manipulated on the higher voltage. That is the manipulation element. So we have to observe from the conversion element, the electrical signal. The signal of the electrical signal is converted like a frequency and voltage. So the small amount of voltage and then frequency that is converted into and then higher level. That is the manipulation element. Then data transformation element. So that is we have to transfer the data. So without any change, that is data transfer element. So gears and then shaft, it is a data transferring elements we are using. And then data processing element. So we have to process the element what we are required. So what we are required, that form only we have to process in this one, that is a processing element. Some of the components that is in a display is in a digital form, analog form, and then monitoring the values, everything is in one. So based on that one we have to process this one. So the processing elements we have to include in the data processing elements. And then data presentation element. So the final form, that is the result form, that is a monitor level. So the monitor that is the presentation element. Monitor is the presentation element. So CCTV and then monitor, everything is in the and then presentation element. So the required form, it will be output level. So these are all the basic elements we are using in this one. So see one example in the Bourdon tube temperature measurement instrument. This given is one is Bourdon tube temperature measurements. So here we are going to measure the temperature from this one. So the basic elements of the instruments are in here. So the various elements we are using, one is capillary tube and then spiral Bourdon tube and then linkage of gears, that is linkage is connected with the spiral Bourdon tube and then the linkage is connected with the gears, and then one of the pointer is pivoted on the gear. Then it is the display unit, the scale is the display units. So we have to measure that the temperature. So the temperature bulb, so inside pressure, so based on that pressure, so increasing that the temperature, so the Bourdon tube will be engaged, then spiral Bourdon tube will be engaged, then it will connected the linkage gear. So due to this one, the gear will be rotating. So based on that rotation of the gear, so the pointer will be displayed in the variation in the scale. So here various elements. So this one is primary sensing element, only observe the energy of the temperature. Then it will converted into capillary tube. So the energy is converted into capillary tube by the pressure. So from that capillary tube, that energy is converted into spiral Bourdon tube. So this form is, that is a data transmission unit. So this data transmission unit without any change from the capillary tube. So based on that elongation, so this will be engaged. Then it is connected with the linkages. So from that linkages, this one is data, that is a processing element. So due to that rotation of that gear, so it will display. So this one is display unit, that is a display unit, final unit element of this one. So this is the example for the any one component. Now we are going to discuss about the sensitivity. So the sensitivity of the important of the instrument. So sensitivity is denoted by K. So sensitivity is, that is a ratio of magnitude of output signal divided by magnitude of input signal. K is equal to magnitude of output signal to magnitude of input signal. So this is the sensitivity of an instrument. So sensitivity is a important one of the instrument. So this one is single instrument. We can take and K is equal to magnitude of output signal divided by magnitude of input signal. Suppose we are using more than one instrument. So we are using more than one instrument, like K1 is a one instrument, and then K2 is another one instrument, K3 is the another one instrument. Suppose we have to use 3 instruments. So we have to find out that the overall sensitivity of an instrument. So the input of the K1 instrument is Q1 input, and then output of the K1 is equal to, that is Q1 output of the K1. So sensitivity of the K1 instrument is Q1 by Qi, that is Q1 divided by Qi, because Q1 is the input output device and then Qi is the input value into second instrument. So input of the second instrument is Q1, and then output of the so input of the second instrument is Q1, output of the second instrument is Q2. So sensitivity of the second instrument is Q2 divided by Q1, and then sensitivity of the third instrument, that is Q output. So output divided by input, magnitude of output divided by input, QO divided by Q2. So this is the sensitivity of the overall instrument, K1 into K2 into K3. So this one is the sensitivity of the overall system. Suppose we have to use more than one instrument, means we have to find out that the overall sensitivity. So this is the sensitivity of this one. And then next one is repeatability and reproducibility. Repeatability and reproducibility. So what is the meaning of repeatability? Repeatability. So consequently we are taking a reading in the instrument. We are using that the instrument, we are taken 4 or 5 readings. So that readings are different. So for example, so one here, that is a constant value is 10 mm. So we are using that the instrument. So we are taking the 4 measurements for 9.97, 9.98, 10.01, 10.02. So it will give various and then measurements by using single instrument. So that is same instrument. We are using that the same instrument, same observer, and then same place, that is the repeatability. So we can take the reading again and again. So that is by using same instrument, same observer, and then same place. Certain time period we have to measure that the reading, that is the repeatability. So and then reproducibility. What is the meaning of reproducibility? The same one we are going to take the reading. So repeatedly we have to take the reading at the different instrument. Take the different instrument, and then different observer, and then a different place. So it will not give the correct reading. Some of the errors on the instrument, So we have to correct the error on the instrument by using repeatability and reproducibility. We have to concern based on that, find out that the error of the instrument. So repeatability means same thing. Everything is in a same instrument, same observer, and the same place. But reproducibility is the different instrument, different observer, and then different place we have to measure that the component. So suppose some of the instruments instrument is error means easy to identify. And then next one is accuracy. What is the meaning of accuracy? Accuracy means, so the taken value is compared with the standard value. Taken value is compared with the standard value. So that is the accuracy. So the accuracy is only comparison with the standard value. Standard value and then compare with the taken value. So this difference is the accuracy of an instrument. So each and every instrument we have to check that the accuracy. The accuracy is the important one of that instrument. So because the value will be, we have to add it in the instrument based on that accuracy. So the standard value and then taken value, that is a difference is the accuracy of an instrument. And then next one is precision. What is the meaning of precision? So the precision is exactness of the taken value. Exactness, degree of exactness. Degree of exactness. Exactness of taken value. So this is the precision one. Degree of exactness of the taken value is the precision one. Suppose we have to take the reading of an instrument. You have to take the reading of an instrument. So suppose that is a value, that is a known value of an instrument is 100 megapascal. This one is known value. Now we are going to find out that the accuracy and precision of an instrument. So the known value is 100 megapascal. That is the standard value. So we can take that the taken 6 readings by using that the same instrument. So the first reading is 103 megapascal. Second reading is 102 megapascal. And then third one is 104 megapascal. And then fourth reading is 102 megapascal. And then fifth one is 103 megapascal. And then sixth one is 104 megapascal. So we can take in the reading of 6 readings. By 6 readings, it is a various readings given by the instrument. So the instrument is having various accuracies and precisions. Now we are going to find out that the accuracy of the instrument. So the accuracy is only compared with the standard value. The standard value is 100 megapascal. So taken value is 102, 103 and 104. So the maximum value is 104. So we can take the maximum value 104. So 104 megapascal minus 100 megapascal. So now the difference of these two reading is, that is 4 megapascal. Then we have to find out that the percentage of accuracy, that is means, so 4 divided by 100, that is equal to 4%. So the accuracy of this instrument, we have to taken that the reading of 6 readings. So these 6 readings we are using that the instrument accuracy is 4%. And then precision of an instrument, we have to find out. The precision means degree of exactness of the taken value. So degree of exactness. So first we have to find out that the average of the instrument. So the average value first we have to find out. 103 plus 102 plus 104 plus 102 plus 103 plus 104 divided by 6. So and then the average value. So average value is 103 megapascal. So we have to compare with the average value. Compare with the average value with all that values. So here 103, first value is 103 megapascal. Here the precision is in 0. And then here the precision is 102, that is minus 1. The value is in minus 1. Here third one is 104, that is plus 1 is the precision, and then fourth one is minus 1 is the precision, and then fifth one is that is 0, and then sixth one is 104, that means plus 1. So the major maximum and a minimum. So the maximum is plus 1 and then minimum is minus 1. So the precision of an instrument is plus or minus 1 megapascal. So that is the precision of an instrument. Okay, are you clear? So this is the accuracy and a precision. So accuracy of an instrument is only we have to compare with the standard value. It is in the percentage level. So the precision is only degree of exactness of the taken value. So that only is in a value variation, that is plus or minus 1 megapascal is an value. So this is an accuracy and precision of an instrument. And then next one is we are going to discuss about the errors. Now I am giving one more diagram. So the comparison of accuracy and a precision, accuracy and a precision versus. So this one is frequency and a dimension. See, and then this one is dimension. Now we are take 6 readings of this one. So one is average value, another one is standard value. So the standard value, this one is average value. So the difference of standard and then average value is that the error. So now we are taking the 4 readings of this one. Here the error is more between average value and a standard value. So it is precision, that is accuracy is less. Accuracy is less, but see the in the dimensions of the degree of exactness is close to the average value. So this is one a precision of this one. That is not accuracy, but this one is precision, not accuracy and precision. And then see this one. Next one is this one is average value. This one is error. So degree of exactness. See, so average value is close to the standard value. So this one is accuracy of this component. So here degree of exactness is less. So it is not a precision but accurate component. It is not a precision but accurate one. And then next one is, suppose I am giving another one. Average value. Here there is no error. See, this type of instrument is having higher accuracy and higher precision one. So here there is no error. Error is 0. So this one is, this instrument is higher accuracy. And then degree of exactness is very close to the standard value and average value. So higher precision of this component. So these are all the difference of accuracy and precision. And then next one is errors. So in an instrument, normally in an instrument it is having some of the error. So that error only we have to discuss in the accuracy and precision one. So the accuracy, that is a standard value, and then taken value, that is difference. So how to it is will differ, and we have to identify in the errors. So errors are classified into 3 types. So normally in a comparison, that is a difference of measured value and then standard value. So that is called error. So the first type is static error. And then second one is reading error. And then third one is dynamic error. Static error, reading error, and then dynamic errors. So static error, it is classified into various types. So based on that environment, based on that characterization of the instrument elements. So because of this one, we have to identify that the static error. So second one is reading error, and then third one is dynamic error. So in the static level, in the instrument in static level, we have to identify that the errors. So the error is nothing but that is a measured value, difference of measured value and then standard value. Due to that characterization of this one, and then environment based, higher temperature, higher cold, based on that one, the instrument will be due some difficulties. So that is the static error. And then next one is reading error. So the reading error, so due to that reading based on that observer, so it is reflected in the glass. So in the glass, image glass only, it is reflected based on that one. So the reading error will be displayed. And then third one is dynamic error. So the dynamic error only majorly it is classified into two types. One is systematic error, another one is random error. Two type of errors. So what is the meaning of systematic error? So systematic error or controllable error. So we have to identify that error easily. So that is the systematic error. For example, we have to manufacture one component, so one of the gear. So we have to measure that the gears. So after completed two or two teeth, it will give that the value is different the value. So that is the systematic error. Easy to identify that the error, and then easy to identify that the error. And the next one is random error. So we cannot identify that the error. So that is a random error. So that is these two errors majorly in the dynamics one. So suppose the instrument given the random error means, so we can replace that the instrument that is better. So in the systematic error on the system and the instrument is easy to identify and then rectify, it will use again, it will be used in this one. So these are all the different type of errors we have to use. This one is basics of the measurement system. And then next we have to discuss about some of the linear measuring instruments, angular measuring instruments, and then advanced measuring instruments. So what is the meaning of linear measuring instruments? We have to measure the length, height, width, depth, diameter, internal diameter, outer diameter. So we have to check it by using the instrument. So that is called linear measuring instruments. So various type of linear measuring instruments we have to use. So before we have to start this one, we have to study about some of the limit gauges. So the limit gauges is one of the linear measuring instrument. That a limit gauge only we cannot measure that the component. We cannot measure that the component. Only we have to inspect the components. Where we are using this instrument. So this instrument is used to the mass production. So that mass production is identical component they are producing. More identical components the company will producing. Then we have to check that the component. So all the components we can use by using that the linear measurement. It will take more time. To avoid this time, so we are using that the limit gauges. So the limit gauges only designed based on that working and then standards. Working standards. The company will decide that the standard one. So that is the limit gauges. that is inspecting component. So how can we design that the limit gauge? So that is a major rule. So we can check the hole diameter and then shaft diameter. So the hole diameter is the inner diameter, we have to check it, and then shaft diameter is the external diameter. So we have to checking that the external diameter. So in this limit gauges we have to design in the two things. One is go side and then another one is no go side. Go and then another one is no go. So what is the meaning of go and no go? So go side we have to check the component. So go side will enter that the component. It will enter in the component. The no go side means it will not enter in the inside. So that is a no go side. So how can we design that the go and a no go? So that is a main rule. So for example, we have to check one of the component. The size of the component is, that is 10 mm. There is the diameter of the component is 10 mm. So here we have to design the limit gauge for this one. So exactly we cannot produce that the 10 mm hole. So that is the difficult one. So that's why, so require some of the tolerance. The company that is giving some of the tolerance in this one. So suppose it will give the tolerance level is plus or minus 0.03 mm. 0.03 mm given. So now the lower limit level and then upper limit level. We know that lower limit and upper limit level. That is lower limit level is 10 minus 0.03. And then upper limit is 10 plus 0.03. So that is the limit size. So the lower limit size is 9.97 mm. The upper limit size is 10.03 mm. So these are all the variation. So lower limit side and then upper limit side. Now we have to design, that is a lower limit and then upper limit levels. So I already told go and a no go. Only we have to design and then go and a no go. The go side and the no go side only designed based on that lower limit and a upper limit. So for example, so this one is one side. One is go side, another one is no go side. So suppose it taken as this one is go and then this one is no go. So go side will enter that the hole and then no go side it will not enter that the goal. So this go side and then no go side only designed based on that upper limit and then lower limit. So lower limit size is 9.97 mm. So the lower limit it should be in go side. So the go side is 9.97 mm. The size of the gauge go side is 9.97 mm. And then no go side, the size of the no go side is 10.03 mm. 10.03 mm. So this is one is no go side. Very clear? So now 9.97 mm. Now we are going to measure that the hole. So go side it will enter. So go side it will enter from 9.97 mm to 10.03 mm. Okay, are you clear? So because the size of the go side is 9.97 mm. Okay, we can measure that the various values, that is 9.97, 9.98 or 9.99, 10, 10.01, 02 up to the level of 10.03. But no go side it will not enter. So only it will measure that the upper limit level, that is 10.03 mm. Okay, are you clear? So this one is the design of the limit gauge. So go and a no go side. Suppose we have to inspect that the component. The component size, no go side, it will not enter that the component. we will reject the component. And then we can modify it because the dimension is less than 9.97. Are you clear? So 9.97 less than 9.97, the value is we can alter it. Suppose 9.96 mm. So 9.96 mm of the hole size is, projection of the hole size is 9.96 mm. Now the go side it will not enter. We will reject that the component, but we can alternate it. Okay, so to enlarge that the hole up to 9.97 or 9.98, and then another one rejected component. So it is having, that is a 10.05 mm. Go side it will enter. 10.05 mm means go side it will enter. No go side it's also it will enter because the size of the no go size is 10.03. So now 10.05 mm, so it will enter. But the component we cannot alternate because the size of the hole is very large size. Okay, are you clear? So this is the basic method to design the limit cages. So the limit cages only designed based on the working standards. Okay, are you clear? Then we have to move the another topic. And then linear measuring instruments. So the first one is, so normally we are using, that is vernier caliper. Vernier caliper. So various type of vernier calipers we are using. Okay, are you clear? So I will explain some of them. I will show some of the diagrams of the vernier caliper. Okay, we are using various instruments in the linear measuring instrument. So the first one is vernier caliper. So various type of vernier calipers we are using to measure the instrument. So what are the linear measurements we can measure by using the vernier caliper? So normally we have to measure the external diameters and then internal diameters, depth, thickness of the component. So these are all the basic measurements by using the vernier caliper. So see, in the vernier caliper it is having various instruments, various components. So here one jaw, it is a fixed jaw. So this one is fixed jaw. So and then this one is movable jaw. So the movable jaw only adjusted based on the size of the instrument. Smaller size of instrument only we can measure by using the vernier caliper. So in this one, then we have to measure the distance. So the adjustable one, movable jaw, to measure the component. So insert the component between the fixed jaw and then movable jaw. Then the both surface will touch by the fixed jaw and then movable jaw. Then we have to give the clamping. That is a clamping screw will clamp this one. So it is having two scales. One is main scale, another one is vernier scale. So the number of divisions based on the accuracy one. So we are using the vernier scale. So the division of accuracy is very less. So by using this one, the accurate value we are getting. So normally in this main scale, so we can measure, for example, 10 mm, 11 mm, 12 mm, 13 mm. So this one is we can measure by using this one. So in this vernier caliper means, so we have to use 0.00 level. Okay, 0.02 and 0.3, 0.4 and this various levels we can use by using the vernier caliper. That's why we are using the in the vernier scales. So this division give the accuracy of an instrument. So it is the vernier caliper having different type of vernier calipers we are using. So type A, B and a C. So type A we can use only the external diameter. So these two things not available in the type A1. So the external diameter we can measure only the external diameter of the component or thickness or height, depth, height, everything we can measure by using this one. And then type B. So this type of vernier caliper is in a type B1. So the internal diameter we can measure the internal diameter by using the knife faces. So and then type C we can use only to mark the component. So to mark that the levels, so 10 mm we have to mark 10.02 mm, we can measure that the component. So we can measure that the component by using this one. So it is required some knives in this the sharp edges. So the sharp edges are attached in this part. So the part will be attached. So that one is used to measure that the value, that is a component in this component. So by using easily, that type of vernier caliper is type C vernier caliper. So this one is basic type of vernier calipers we are using. Okay, the next one is vernier height gauge. Heavier components. So in the lighter components we can use by measure the height by using the vernier caliper. By heavier components, the heavyweight components, we can measure the height by using the vernier height gauge. So the vernier height gauge only fixed on the surface plate, and then the heavier component is located on the surface plate. So both and then faces are in the horizontal surface. Then we can use the and then vernier height gauge. So the similar to the vernier caliper is having two scales. One is main scale, another one is vernier scale. So similar to this vernier caliper we can measure by using this one. So only it is using to move upward direction, and then we have to measure that the component is easily. So the base of the component only located in the surface plate. So the bottom of the component only located in the base of the surface plate. Then we have to measure that the height of the component by using the measuring jaw. So the both ends, one end is touched by the surface plate, another one end is touched by the measuring jaw. So the measuring jaw we have to fix it. So and then it shows that the value in the main vernier scale 1. So this is the basic working principle of the vernier height gauge. And then next one is vernier depth gauge. So normally the vernier calipers and then vernier height gauge, so this one is visible one. So we can measure that the external diameter. So some of the components we have to measure that the internal diameter. So we cannot see that the measurement. So just like this one. So in this one we have to measure that the depth of the component. In this depth of the component we have to measure by using the vernier depth gauge. So how to locate that the component, the base, measuring phase, how to locate it. So this one is, it is not correct, because in this one, so the scale only the move of main scale is in an inclined position, but both ends, the both surfaces, the bases are in inclined one. So we cannot locate on these faces and horizontally. So horizontally we can locate it. So automatically the scale is in a vertical position. Then we have to measure that the value. So this one is wrong method. So see the another one. So here we have to move that the scale, which it is not visible. It is not visible one. So that's why we can check that one. So in this one the faces only touch on the surfaces, and then main scale, that is main scale only touch inside in the bottom. So and then we can measure it. So this method also in a wrong method to measure that the by using vernier depth gauge. So another one, see in this we have to touch one surface, the two surfaces are inclined position. That's why we have to touch on the one surface, but it is not in the horizontal position, it is some inclination position. So we have to and then draw in horizontal position, and then we have to measure that the component. So these three methods is wrong to measure that the component. So only how to measure that the component means, that is a main scale only touch on the bottom, and then measuring surface in a horizontal position. At the same time it will touch on the surfaces. Now it is in a surface, it will touch on the surface. So this is the method to measure that the vernier depth gauge. So remaining we have to calculate that the value, main scale and vernier scale reading similar to the vernier caliper. So the method only we have to know how to measure that the components. And then next one. Next linear measuring instrument is micrometer. So normally in the vernier caliper, its least count is 0.02. So this least count is 0.01. So the accuracy is more compared with the vernier caliper. So in this micrometer, similarly it is having two types. That is one is anvil, fixed anvil. So another one is movable anvil, that is called spindle. And then we have to lock the spindle by using the lock nut. So it is having two scales. One is main scale, another one is thimble reading. Based on the rotation of the thimble, so it will be varying. This one, the value will be varying. So now we have to measure the component. So the lightweight components we have to measure by using like this type of and then micrometer. Now we have to fix the component between these two things. So one face is touched with the fixed anvil. So the surface, flat surface component only we have to measure by using this type of and then micrometer. So one surface is touched in the anvil, fixed anvil, and then another one surface is touched in the spindle. So the touches of the spindle based on that rotation of the thimble. So now we are using the ratchet drive. So it will be rotate and then the component, it will touch the component, then it will make one sound. So and then we have to stop that and then give the pressure on the component. So now we have to measure the component. So and then we are getting the value. So this is the method to measure the component by using the micrometer. For the more accuracy purpose, we are using micrometers. So we have to measure the external diameter and then external diameter and then thickness and then height we have to measure by using these micrometers. So the micrometers is having various types are available. So for the anvil shape will be changed based on the size of the component. So we can see some of the types of components. So previous one we can study about we can measure the outside micrometer. Outside micrometer only measure the outside diameter of the component. So next one is inside micrometer. So now we have to measure the inner and then diameter by using inside micrometer. Some of the components we have to measure inner sides by using the inside micrometer. So the inside micrometer, so the shape of this one, so this one is fixed anvil and then another one is this a movable one. So based on the rotation of the thimble, it is moving in the external linear direction, moving in a linear direction. We can measure the component and then internally by using inside micrometer. And then next one is thread micrometer. So we can measure the thread. So the thread, it is having various measurements. So external diameter and then minor diameter and then thread diameter. We can measure all these things by using the thread micrometer. So in this thread micrometer, it is having some anvil is different from the ordinary micrometer. See this anvil. So it is fixed only on this thread. So thread form and then internally we have to move in the thread. So the minor diameter we can measure by using the micrometer. So the shape of the spindle, and then shape of the and then this one. So these two things we have to measure. The anvil shape and then spindle shape will be differ by compare with the another type of micrometer. So these two type of micrometers we have to discuss in this one. So this micrometer we have to check it. Micrometers we have to check it by using this thread micrometer level. And then next one is micrometer depth gauge. So micrometer depth gauge we have to use in this measure the depth of the component. So the previous one we have to discuss in the vernier height gauge, vernier depth gauge. So the vernier depth gauge we have to measure in the depth of that component. Similarly, we have to measure the depth of the component by using the micrometer depth gauge. So why we are using micrometer depth gauge in this one means so to get the accuracy of the component. So the accuracy of the component is important one, that is a main thing. So we can measure the component. So in this vernier caliper, so we can measure that the accuracy level is, for example, 10 mm means 10.02, 10.04 and then 10.06. So the value we are getting the value by using the micrometer depth gauge. We are getting that the value is 10.01, 10.02 and then 10.03. So similarly we are getting the accurate level more than and then vernier caliper. So the various type of micrometers we are using, some of the digital type of micrometers and then bench type of micrometers we are using. So why we are using digital type of micrometer means, so the accuracy we are getting that the accuracy. So based on that observer, the value will be differ. So observer to observer, the value will be differ. So some of the persons we have calculated 10.01 means, so some of the persons we have calculated 10.02. So we are getting that the digital micrometer, it will display, this is not give the variation on this one, so it will give the accurate value on the micrometer and the digital type of micrometer. So that is the main thing. And the next one is bench micrometer. So the heavyweight component we can measure by using the bench micrometer. So we can rotate the spindle by using the thimble. We are giving more pressure on this one, more pressure on this thimble means, so we cannot get the value, we cannot get the value. That's why, so we are using the pressurized pressure gauge we are using in the bench micrometer. See the diagram in the bench micrometer. I already told, so the V anvil micrometer gauges. The shape of the anvil is in a V shape. So this micrometer only to measure that the gears and then screw gauges, everything we have to measure by using the V anvil micrometer. And then dial micrometer caliper. So dial micrometer caliper is nothing but, that is in the display is in the dialer gauge. That is we are using the dialer gauge, it shows that the value. And the next one is digital micrometer. So digital micrometer we have to use, the display of the display value is in a digital form. So the digital form display is used to give the value of accuracy, that is a main thing. So digital micrometer mostly we are using to getting the accuracy of the component. And then next one is bench micrometer. So in a bench micrometer we are using for the measurement of the component. So normally it is having the micrometer, it is having two phases. One is that is an anvil, another one is the spindle. So we can touch the component. Suppose we are giving the more pressure of that shaft, we cannot know that what is the pressure on this shaft, we don't know about the pressure. To identify the pressure of this component, so and this we have to identify by using in the dial gauge in the bench micrometer. So in between we have to set the component. So we are giving more pressure on this shaft. So in the display will be varying the pressure due to that compress this one, this anvil, it will shows that the variation in the value. So that's why we have to set that the dial gauge in the micrometer. So this bench type of micrometer we have to measure that the heavier components. So that is a main thing. So these are all the major type of micrometers we are using to measure that the internally and externally dimensions. So that is a main thing. And then next one, linear type of measurements. The next one is comparator. So in the previous one, so we have to measure the components, how to measure the components, and then the comparator is one of the comparison of an instrument. So in the mass production we cannot measure the components, so by using the limit gauges. So the limit gauges we are using to measure the holes only. So to measure the external diameter, external dimensions by using the comparators. So the comparator only compare with the standard value, so whether the component is in the standard level or not, to identify it by using the mechanic, some of the comparators we are using. So many comparators is there. One is mechanical comparator, electric comparator, and a pneumatic comparator. So these are all the comparators we are using. So comparison, so the standard value, so that is a main thing. So in this one, mechanical comparator. So normally in the mechanical comparator we are using as a dial gauge as a mechanical comparator. So this dial gauge as a mechanical comparator. So how can we set the standard value in this one? So standard value we can set it, and then we can check that the components, the identical components we have to check it one. So this one is the component. So this component is in the standard value or not, to identify by using this component in the instrument. So we can set it by using the slip gauges. So height, that is the external dimension. Suppose the external dimension is 25 mm. So the standard value only accepted by the international level, only we have to set it by using the slip gauges. So the slip gauges we can ring that the slip gauges on this component, the base, we can set it firstly. we can set it firstly and then set the point in the 0 level. Then we can measure that the component after removing that the slip gauges, so it will shows the value. Then we can using that the component, we are using that the component, then we can, the plunger is moving upward and then downward direction based on that variation in the component. So suppose component height is more with the standard value, means the plunger is moving upward direction. Suppose the component is lesser than the standard value, means so the plunger is moving downward direction. So due to that movement of the plunger in upward and then downward direction, it will shows the value in the pointer level, so in the dial gauges. So that is a main thing we have to use in the mechanical comparator. So the dial gauge as a mechanical comparator, we have to set the standard value by using the slip gauges, then we have to compare the standard value. So this is the basic working principle of the mechanical comparator. So another one is electrical comparator. So electrical comparator, so used to compare the component. So this one is the workpiece. This workpiece only we have to find out that and then measurement. So we cannot measure the component. So that is the main thing. So we cannot measure it, but we can compare the component. So compare means with the standard value. Initially we have to set the standard value. So initially we have to set the standard value. Then we have to measure the workpiece. So here the main components in the electrical comparator. So here one shaft is connected with the armature. That armature is designed by an iron armature we are using in here. One end is connected with the shaft and then another one end is connected with the plunger. So that is a main thing. And then we are using the coils. So the coil is and then coil are fixed and then given the proper gap, uniform gap between the and then coils. So we can fit the armature, that is between the coils, give an uniform distance with the coils. Then the coil is connected with the amplifier. So the coil is connected with the amplifier. So then the amplifier is connected with the readout system. So any one type of readout system, whether it is in a digital system or analog system. So what is the purpose of amplifier here we are using? So the signals is conversion, the electrical signals. So from this one, how we are getting the electrical signal from the iron? So the electrical signal, that is variation. Now it is in a uniform distance is given. Now we have to set at a 0 value. So here there is no current, there is no current is increasing, there is no current increasing in this one. So it is shows that the 0 level. So suppose we are using the workpiece height is more than the standard level. So the plunger is moving upward direction. Then the plunger is moving upward direction, the armature also moving upward direction. Here the distance between the upper coil and then plunger is less. So here it's a more distance. It is producing the more current. Due to that, by using the bridge rectifier, and then the current will be producing more. That current signals will be and then absorbed by that amplifier. That only is converted into magnification. So the current signal is and then converted into magnification. For the purpose we are using the amplifier in the electrical comparator. Then the value is displayed in the display unit. So here we are using the analog system. The meter shows that the variation in the value. So and the points will be given based on that, and then divisions based on that we have to calculate that the table 1. So that is the main thing. So this one is basic working principle of the electrical comparator. So the mechanical comparator and then electrical comparator. So another one type of comparator is pneumatic comparator we have to use. Another one type is Solux pneumatic comparator. So normally pneumatic comparator, it is working based on the back pressure system. So pneumatic comparator, in the pneumatic means that is we are using air as a fluid in this system. So the air is compressed from that atmosphere, and then compressor we are using only, that is observe that the compress that the air, then that air will be filtered by using that the air filter. So the air filter that the air, and then regulate that the air uniform pressure air will be enter in the control orifice. So here we are using one control orifice. So the control orifice allow that the air, that is the uniform pressurized air only allowed to the flexible tube. So and then remaining air it will be enter in the dip tube, then the dip tube through the water tank. So through the water tank, so from the dip tube through the tube, the pneumatic, that is the air will be enter in this one. So the excess air, suppose the air is more, that is a compressed air is more, it will enter in this control orifice, means so automatically the back pressure, due to that back pressure it will enter inside that the tank, so the water tank. So due to this one, so the air bubbles, the excess air, so converted and air bubbles in this tank. So that is a maintain the excess air bubbling to the top. So that's why the variation of this height, the height will be maintained at the standard level, that is capital heights. Capital heights is maintained at the standard level. So that is a main thing. So from that control orifice, so the air is uniform pressurized air, it will be enter in the flexible tube. So flexible tube. So through the measuring jet. So the measuring jet, that the distance will be based on that component size. So we have to increasing or decreasing that the level, tube will be increasing that the length. So here we are going to measure that the component. So from the flexible tube, so in this size is our open side, so the air will be exhausted through this one. So the uniform pressure it will be enter in this one, means so automatically there is no restriction, means the air will be and then escaping through this outside one. Suppose the length will be varying, it will be restricted that the air, so the diameter will be decreasing, so automatically it will make a back pressure on it. So back pressure on it, so the automatically the pressure it will be enter inside that the tube, manometer tube. So it will, the back pressure will compress that the air, compress that the water. So some of that variation, so there is no problem, means so the height will be maintained at this level, that is a small h also maintain this level. So some of the restriction on this one, so the back pressure it will enter in this one, automatically it will compress this one, and then we have to maintain that we can measure that the height value. So the height value we can find out that the height value, then we can substitute the value in this formula, that is P is equal to pressure. We know that the formula P is equal to rho G H. So we know that formula. So the height value only we have to substitute in this one. We know that the value height value. So suppose we know that the height value, and then we substitute that the value, we can get that the pressure. So due to that pressure variation, so we can identify that the component whether it is a compare standard or not. So some of the variation in the height means, so suppose there is no variation in the height, means so the component is in standard form. So the variation in this height means it is not in standard form. So that is the main thing to identify by using the Solex pneumatic comparator. So it is not measuring instrument, only to compare that the standard value, that is the main thing. So based on that back pressure of this one, so the back pressure is creating based on that restriction on the area, so reducing or increasing that the level of the component size. So due to that one, the back pressure will be increasing. So that is a main thing. So another one type of and the pneumatic comparator is differential pneumatic comparator. The next one is differential comparator. So already we discussed about Solex pneumatic comparator, and then so next one is differential comparator. So the differential comparator also working based on that and then back pressure. Here air at constant pressure it will enter inside this one. It is having two control orifices, orifice 1 and a orifice 2. So orifice 2 orifices we are using, one control orifice to measure that the workpiece. So another one control orifice is used to and then Is it the 0 level, set that the 0 level. So here first how to set the 0 level by using this one control orifice means, so here it will enter in this one. So now we have to measure that the pressure indicator that the value. So the value is not in 0 means, so we have to adjust that the reference Z. So adjusted that the reference Z, so automatically the releasing that the air and the pressure will be decreasing. Suppose we have to lock that the component means the pressure will be increasing. So based on that one, so we have to adjust that the nozzle, then we have to set that the 0 level. And then another one is control orifice 2. So here we have to measure this component. So here only it shows that the value in a 0 level. This one is to measure that the component. So here the measure that the component, it will move that the component. So it will shows that the value, shows that the value. So the both values are in the 0 level means, so the component is on in standard level. Suppose it is not shows that the value in variation. So in the instrument variation, the component is in a, is not correct means, so the back pressure gives that the varying that the value in the pressure indicating devices. So that's why we can find out that the pressure variation by using that the indicator. One is used to adjust that the 0 level, so another one used to measure that the component, the measuring head. So we can measure long length of the component. So the previous one, that is a length, we can the tube, we can the length, we can measure that the component is very small type of component only we have to measure, but a differential comparator, so we can measure very lengthy component measure easily by using the differential comparator. So that is the main thing. So these are all the linear measuring instruments. So the linear measuring instrument, these instruments only to measure that the component and then compare with the standard one. So on the next one is angular measuring instrument. So various type of angular measuring instrument is there. Mostly we are using the sine bars. Sine bars we are using to measure that the components, that is the main thing. So how can we set that the sine bar? What is the design of the sine bar? Only we have to discuss in this one. Next one is sine bar. So sine bar we have to use to measure that the angular measurement. So the linear measurements we have to measure length, height, depth, and then on thickness. So these are all the measuring the instruments. So the angular measurements we have to measure by using that the sine bar. So how to measure that the sine bar? So normally we have to measure that the inclination of this one. So this one is horizontal surface. So this one is component inclination. So this inclination only we have to measure. So how can measure this angle theta? By using that the sine bars. So that is the main thing. So here we are going to measure that the theta, that is an angle. So two values are known value. So this inclination we don't know about that the inclination. This inclination only we have to measure. So this one is base one, this one is height one. So two known values. So here we have to identify that the known value, that is heights value. So by using some of the instruments. And then another one part. Next one is this one. This one is, that is a standard value. Some taken some of the standard value. So these two values, that is two values we can take. So what is the sine theta? Sine theta is equal to opposites by side by hypotenuse. So h divided by L. So this one is we have to find out this one. So the height, how to measure that the height? So this is the component one. So how to measure that the height? So this one is unknown value. So and some of the standard instruments we are taking. So which one is standard instrument means? So slip gauges we are taking that the slip gauges from that bottom we have to and then add that the slip gauges according to that height. So and then first we have to set that the sine bar. So sine bar it is having various standard sizes. The roller center of the roller to the center of the roller, that one is the standard value. So the standard value only we have to measure it. So that is a length L, this one is standard value. So the unknown value is the height is the unknown value. So the unknown value measured by that the slip gauges. So slip gauge is on a standard values. Then we have to add that the slip gauges based on that height. So then we have to find out that the the height. Finally, we can calculate. So that is now the known value is h and L. So then we have to find out that is the sine inverse of h divided by L. So this is the method to measure that the inclination of the component. So that is the main thing. So in this sine bar, where we are using the sine bar. So now the components, so measuring components is on heavier components, lighter components, and then so large size of components we have to use it. So how to set the component. So some of the components are the shapes, some of the components are conical shape, cylindrical shape. So all the shape of the components we can use by using the sine bars. So this is the method is given. See, this one is method is given how to measure this one. Now I already told the theta we have to find out that the theta, this is the instrument or that is a component, there is a component inclination. So the roller to roller, so center of the roller to the center of the roller, that is the standard size of the sine bar. Then we have to set it, and then we have added that the slip gauges, the height of the slip gauges is h, and then h divided by L, and then find out that the sine theta value. So the smaller components we can use by using this method. Suppose some of the heavier components, how to measure unknown angle. We have to measure that the angle of the unknown angle components. So this is one type of component. This one is sort of medium size of component. So this component, how to measure it. So first we have to fix the workpiece on the sine bar by using some of the clamps. So here inclination, this one is inclination of the component. So the workpiece inclination, one is it is having horizontal surface, one face is in the inclination phase. So we have to measure that the inclination of this one. So the inclination is rest on the sine bar top surface. Then we have to clamp that the workpiece. Then the component, now we have to check that the height of the component. So to increasing that the height, so now this one is parallel to this one, so parallel to this one. So by using that the dial indicator, we have to check that the and then parallel of the workpiece. So the parallel of the workpiece shows in the 0 level, means we have to stop to add that the slip gauge in this side. Then we have to and then substitute the value in this formula. So the height value, that is a height value, that is a slip gauge on this one, and then a length L value as the and then component one. So that is a sine bar standard value, that is a L1. So the smaller components, this is a smaller component, we have to check that the angles. Heavier components, heavy weight components, we have to measure it. How can we can set that the sine bar? So the various methods we have to set the sine bar and then check that the and then angle. So that is a important one for this one, the based on that component one. So measurement of the unknown angles for heavier component. So this one is component is in heavier components, we cannot move it, and then we can set on the surface, and then surface only in the flat surface. So that is the main thing. So we have to set the component on the flat surface, otherwise we cannot get the angle or accurately. So the flat surface we can set the component. Now we are using two vernier gauges. So vernier gauge 1 and then vernier height gauge 1 and vernier height gauge 2. Two gauges we are using. Then the sine bar we can and then locate like this position. That is the main thing. So locate this position. Then we have to check that the height of this component. So by using this one roller. So middle roller of the middle, we have to touch that the component, that is a surface, that is only touch on the middle of the roller, because we have to set that the only middle to middle of the roller. So that is the measurement of the L. So that is the main thing. So this point only touch on the middle of the roller. So another one side, so another one vernier height gauge is touch on the middle of the roller. Now we are getting one value from H1 and then H2. So we need only H value. So what is the H value? H1 minus H2. H1 minus H2, we are getting that the H value. H1 minus H2. That is a H value. Then we have to substitute in this formula for H value in this one, and then H divided by L, we are getting that the inclination of theta. Theta we are getting that the theta. Then find out this one. These are all the flat surface components. So rectangular component, rectangular size components, one face on its rectangular surface. So by using easy to measure that the inclination. Some of the conical components is there. So we have to check that the inclination of the conical component. So that is the main thing. So the conical component, how to measure it. So some of the alteration in the sign bar. So that modification is needed to measure that the component, to hold the component, that is the main thing one. That is a modification of sign bar. So to modify that the sign bar in two ways. One is sign table, another one is sign center. So in two ways we can modify that the components. One is sign table, another one is sign center. We have to use in two ways. So see in the diagram, in the sign bar will be modified in two ways. One is sign table, another one is sign center. So sign table, so we can measure that the conical workpiece. So the previous workpiece we can measure by using that the sign bar. So in this component, the surface, one of the surface is in a rectangular surface or in a square surface. So another one is an inclined surface. So easy to and then clamp by using the sign bar. So this conical surface we cannot and then find the inclination by using this one. That's why we are using to modify that the component. The modification is a very very important one to this one. So the sign bar. So one end of that sign bar, that is a sign bar is pivoted on the table. So that is a main thing. So another one end is so that is an easy to and then moving upward and then downward direction. So here we are using that the centers. So we have to attach that the centers on the both side. So here we have to fit that the conical surface. Now we can measure that the inclination of this one. So this inclination only we have to identify. So this inclination is we have to measure. So how can we measure that the inclination means? So first we have to set that the component center to center. Then we have to add that the slip gauges. So to add slip gauges, then by using that the dial gauge and then measure that the and then angle. Now angle the dial gauge by using the set and level of 0. Then move that the dial gauge from the end to another one end. So from this end to another one end, it will shows that the 0 value. So from one end to another one end shows that the 0 value. Then we have to stop to add that the slip gauges. Then we have to substitute the value in this formula, that is sin theta is equal to h divided by L. Then we are getting that the value of this one. For the conical purpose, conical workpiece, we have to set the sign bar and then sign center. So here also we have to use the conical workpieces and then very complicated components we have to measure by using this one. So both ends are it is having centers. Both ends are it is having center. So we have to set that the components between this center. So here we have to set that the component. So one end is fixed one. One end is fixed in the table. So another one end is this one. So here we have to set that the component in between. Then we have to and then move that the component in upward direction and then we have to check that the component. So normally large length size of components we have to measure by using the sign center. So 200 to 300 mm sign bar. So smaller components we have to use that the sign bar is 100 mm sign bars. So here we are using 200 to 300 mm sign bars. So one of the supporting strap only supporting plate used to and then adjust the center of the black. So that is a main thing. So these two modifications only used to measure that the conical component. Smaller conical component we have to measure by using that the sign table, and then larger size of conical components, so we have to measure by using that the sign center. So the center of the sign center length is more, and then in between we have to fix that the component easily by using that the two centers. So that we are using that the two centers. So this one is to measure that the inclination of the component. So that is a main thing. And then next one is angle gauges. So how to set the angle gauge? So normally in the slip gauges we have to measure in the linear measurements. So we have to add the linear measurements. Now we are using the slip gauges. So these are all the slip gauges, we have to add this one. So it will give the value. So the linear measurements value. So how to measure the angular measurements by using the plug gauges. The next one is angle gauge. So in the slip gauges only you have to unknown linear measurement easy to identify. So using that is a slip gauges. So angle gauge, so the unknown angle, so easy to identify, it will used to support that the measurement of unknown angles in the angle gauge. So what is means by angle gauge? So this one is various gauges, number of gauges it is having. So based on the degree, minute and a second. So in this degree levels it is having 3, that is it is having 5 types. So it is available in this one 1 degree, 3 degree, 9 degree and 27 degree and 41 degree. So various levels in this available 1, 3, 9, 27 and 41 degrees. We have to measure. So the plates are available, and then in this minutes level it is available 1, 3, 9 and 27. 1, 3, 9 and 27. So these plates are available 1 minute, 3 minute, 9 minute and 27 minutes. And then in the seconds level, in then 3, 6, 18 and 30. 3, 6, 8, 18 and 30. So these are all the available now. These are all the available and then angles in the angle gauge. So we are using this angle gauge. We have to measure that the unknown angles by using that the angle decker. So angle decker we have to use it to available this one. So how to measure that the component? So in this slip gauges we have to add that the component means, so we have to add suppose 20 mm slip gauges we are using, and then 10 mm means we have to add this one. So 10 mm, 20 mm, 5 mm we have to add this one. Finally we are getting that the value. So here in this degree, how to measure that the degree? Here it is having one symbol. So that is a symbol. So the symbol is in like this position means, that is we have to add that the angles. So suppose the symbol is in opposite direction. So we have to differentiate from this angle. So that is a main thing. So here one angle is given, so 27 degree. So 27 degree plate is available. So this symbol is like this position. So this one is shows that the value, and then another one angle, the another one symbol is in opposite direction. So this opposite direction we have to differentiate with this one. That's why we are getting that the value in 24 degree. So that value we have to add this value. So 27. So 27 degree. So this one is the symbol is in opposite direction, minus 3 degree, that is equal to 24 degree. So we have to add it, and then add it and then differentiate it based on that symbol. So see another one is, so we require 36 degree, but the 27 degree is in like this position, symbol is in this position, and the 9 degree symbol is in this position. The same position, symbols are in same position. So we can add that the angles, So that is a main thing. So we have to add, how to add that the angles. So that is a main thing to measure that the components. So based on that symbol we can add that the value or differentiate that the value. That is a main thing. And then, so how to measure that the angle 43 degree? Suppose the given value is in 43 degree, how to measure? So 43 degree means, so what is the available of degree? So that one is 41 degree is available. And then, so next one is, see the table. So next one is available is 3 degree. So that is 3 degree in the same symbol side. And then another 1 degree is available, minus 1. So we have to and then insert the component in the opposite direction. See 41 degree in the same direction, 3 degree symbol is in the same direction. Now the value is in 44 degree, but our required is in 43 degree. So we can add that the 1 degree symbol. So the 1 degree angle plate. So the angle plate is in a fitted in opposite direction. Symbol is in opposite direction. So automatically angle is in 1 degree minus. So that is a required shape is. So and then same direction. This one is in a opposite direction. That is 43 degree. And then 24 minute. So what are the plates are available? Angle gauges are available in the 24. So 24 means, so the two plates are available, 187 and a 23. So 27 minus 23. So that one is here the same side. We have to add the symbol and same side. So this side as in symbol is means we have to add this one, that is 24 degree, and then 27 degree, and then opposite direction, that is a minus 3 degree. So that is a main thing. So 27 degree and then minus 3 minute. So that one is, this one is 43 degree. So this one is 24 minute. So 43 degree, 24 minute. And then seconds. What are the seconds? That is 12 seconds we require. 12 seconds we require. 24 and 12 seconds we require. So 12 means, what is the available in this table? 18 and 6 is available. 18 minus 6. So 18 is at this position and then 6 is at this position. So that is the main thing. Here we have to add 18 is in this position, same side symbol. So opposite side automatically it will make a minus, that is a 3 degree. So that is a main thing. That is 18 minute minus and then 6 minute. So that is equal to 12 minutes. So this is the method to increasing that the angle gauge in the angle plate. So why we are using this angle gauge in the angle plate to measure this one means, by using that the angle decker, so to measure that the component, unknown component, so we have to increasing that the angle. So increasing that the angle by using that the angle plate, so then we are getting that the value, to identify that the value through that the angle decker. So that is a main thing. The next one is temperature measurement. So we can measure various flow measurements, temperature measurements, velocity, and then torque, force, everything we can measure by using the measuring instruments. So in this temperature measurements, so we have to measure in various levels. Low temperature level and then high temperature level. So low temperature level we have to measure by using thermometers. So directly in the heating components we have to insert that the component, the bulb, we have to temperature bulb, and then we have to fit the temperature bulb, and then we have to measure that the components. But in the higher temperature we have to measure by using that the pyrometers. So pyrometers, various type of pyrometers is used to measure that the temperature level. So directly we cannot and then touch the and then temperature component, temperature heating components, because it is having more temperature. So we can only measure that the radiation of this component. So that is a main thing. So this is the temperature source. It is producing more temperature. For example, so it is producing more than 3000 degree C. So we cannot measure like this. So we can measure that the component. So we can measure this one by using that the radiation, in the radiation level only measure. So the radio atom only absorb that the radiation. So we have to, and then radiation it is the points. Now the radio atom only absorb that the radiation from that the temperature source. Here we are using thermocouple. So the thermocouple only observe that the radiation temperature, then it will be converted into voltage level. So the voltage level, that is a millivoltage level. So we have to adjust that the thermocouple. So in this radiation by using rack and pinion arrangements. So from that radiant atom, so the distance will be maintained by using that the arrangement of rack and pinion arrangement. This arrangement only moving, that is by moving this one. So from that source only we have to observe that the radiation, that radiation only measured by using that the thermocouple. So the thermocouple, the energy will be converted into electrical energy. This signal, this one is observed signal is converted into electrical energy. That electrical energy is now converted into some of the readout systems. So millivolt meter. So the millivolt meter, this value is converted and then calculated based on the table, standard table of this one. So this is one type of pyrometer. So that is total radiation pyrometer. And then next one is optical pyrometer. So in the total radiation only observe that the radiation through that the thermocouple. So from that the thermocouple the value will be transferred. So that is a main thing. The next one is optical pyrometer. So this optical pyrometer is used to measure the higher temperature. So how can we measure the optical and then the temperature? So it is having one absorption screen. So it only observe that the radiant energy from the sources. This is the heated sources. It is producing that the temperature that radiant only observed through the absorption screen. So this absorption screen will be reducing the radiation level. So radiation level will be reducing. Here we are using one and then circuit, that is a circuit we are using, then again we are using one filter. So through that the eyepiece we show that this one, so the absorption screen shows that the variation from that the temperature, that is a current, that is a voltage. So the voltage will be compared with this and then this one in three methods. One is equal brightness. So the current will pass through that circuit will be same to the radiant. So now the current will be converted into temperature level as per the standard table. So another one is more brightness of filament. So this filament shows that the more brightness. So more brightness means the temperature will be less. The temperature will be less but current is more to reduce the current. So that is the main thing. And then so third one is more darkness of the filament. So the temperature is more, so the current is less. To increasing the current, so it will be compensated in this level of equal brightness. Then we have to calculate the value of this one. So this one is optical pyrometer. So it is shows that the three levels. One is equal brightness and then more brightness of filament. The filament only shows that the value. To compare with the absorption screen and then filament are in the source in the filter part. So here only shows that the value. So first one is equal brightness means the current is on a equal. Now we have to measure that the value. Suppose the variation and then brightness is, that means the current will be, that is the temperature will be less, the current is more. Suppose the more darkness, the current will be less and then temperature is be more. So we have to adjust this one. So this is the method to measure that the optical pyrometers. So normally thermometers we have to measure that the lower temperature, but pyrometer is used to measure that the higher temperature. So higher temperature level we have to measure by using that the pyrometers. So directly we cannot touch that the component in the higher temperature measurement instruments. Only we have to observe the radiation from that the temperature sources by using various source methods. So thermocouple and then some of that the absorption screen we are using to observe that the radiation. Then we have to measure that the component. So this one is to measure that the temperature measuring instrument.